So what did we cover last time? Omar, what did we cover last time? Print functions, and we looked at the class called many-class, and we looked at two functions, two examples. One example was called the equals, we pass it to objects, and another one is called add, and we also pass it to objects and it returns a third object. In your homework I asked you to rewrite those functions as member functions, non-member functions, and friend functions. Okay, so hopefully by now you understand how to rewrite those and you understand what a calling object is and so forth, the rest of the arrangement. Today we're going to talk about two things. We're going to talk about the constant modifier. You already know about this, but there's one extra piece of information that I will add. And in addition to that, we'll move on and talk about the friend functions as operator overloading. So instead of calling the function add, we want to override the operator which is the plus operator. Instead of defining a function which is called equal, we want to override the equality operator. It's much more natural to deal with. Again, they will be written as friend functions, so we already have the basics. This will not be a big change from what we have introduced to the operator overloading. Okay, now as you know, with sometimes if you're passing an object, and we have seen this before since the beginning of the semester, if you're passing an object to a method, then you can do that by two ways. You can either do it by copy or by reference. And if you use the and sign, then what you're doing, you're passing it by reference. And now we already understand that alhamdulillah, assalamu alaikum. Make space for Ali, guys, if you don't mind. Thank you. Okay, so you already understand that if you have an object and you want to pass that object to a function, you can do it in two ways. You can either do it by copy or by reference. Now, if you want to be a bit more efficient, then instead of passing it by copy, what you can do, you can send it by reference. And if you want to make sure that this object is not being modified inside the add function, you make it a constant reference. You know this, and you know the difference between by copy and by reference. Any doubts about it? Anyone? Okay. Now, there's a consequence to this. If this add function does not call any function inside it, does not call any further function inside it, then we are on the safe side and we're done. However, there might be a situation where you have a function called add, and inside that function it's calling another function called input. Now notice that if you're passing amount 1, and through amount 1 you're making a call to input, but you're passing amount 1 as a constant reference, right? And now input amount1.input, this function input itself might change the values inside amount 1. This is an object of type money. What are the values inside the amount 1? What are the private data members? All cents, do you remember? Okay. This input function, most likely, it's going to modify the all cents of amount 1 because it's an input function, right? Okay. Now the controversy here is that amount 1 should be a constant reference and we should not allow it to be modified inside this function. Yet there's another function call which is called input, and it's being called through amount 1, and most likely it will change the all cents member of amount 1. This is a problem. So the consequences are, this input function, we have to make sure that it does not modify any data member of amount 1. And C++ came up with the solution for this. And this is the solution in terms of syntax. Is that if you have any function, like output, a member function, and this function is not allowed to modify its calling object, because you'll have object.output, amount1.output, the calling object. If you know that this function is not allowed to modify the calling object, then you just add the keyword const after the declaration and definition of the function. We have not seen this before. This is new to us. Now we know that we can use const inside the parameter list, right? But this is the first time that we see const outside the parameter list. What it means is the following. This function, which is called output, is making a promise to us that it will not modify the calling object. This is what it means. And in fact, C++ will not allow it to modify the calling object. Okay? So if you say amount1.output, this function is guaranteed that it's not going to modify the old sense of amount1, which is the calling object. You need to do this for both the declaration and the definition. So when you define the function as well, you need to add the keyword const. Okay? So if inside this function you're trying to modify the old sense of the calling object, immediately it will be a syntax error and you're not allowed to do that. Okay? Yes?
What happens if we remove the word const here?
It will be a syntax error because you have to add const in the declaration and the definition.
It won't compile.
It will not compile, no.
So
Yes, sir.
if we don't want to modify it, when we're passing it by reference? Here.
No, this is not the calling object. This is something else. This is the output stream.
Oh.
The output stream is a different story. By the way, the output stream, input stream, and output stream, whether you are passing it as an argument or it's being returned from the function, it's always by reference. Input stream, output stream is a special case. Okay? Fine. Now let's go back to the same example again. We have a function called add, and we're passing it amount1 as a constant reference and amount2 as a constant reference as well. Fine? Now, if you have amount1.output, where's the calling object over here? Where's the calling object? Amount1 is the calling object, right? Output, is it allowed to modify all sense of amount1? Why not? Who said yes? It's being passed as a constant reference, so output should not be allowed to modify the old sense of amount1. Right? This is the point. So this output function has to be declared as a constant function. So again, a constant function, it means the following. This function promises C++, it will promise us that it will not modify the calling object. Where's the calling object? Amount1. How would output modify the calling object? It will change one of its data members. In our case, we only have one data member, which is called allSense. So this function, which is output, because it's a constant function, it will not modify the calling object. Okay? So just to wrap up, if you're passing an object as a constant reference, you do that for efficiency reasons, because you're not passing a copy of the object, you're passing the address of the object. So it's much more efficient. Okay? So you know the analogy. So instead of making a copy of the document and giving it to you, I'll just give you the address and you can access it on the web. And now both me and you have access to the same document. This is a call by reference. If it's a call by copy, I'll print out the document or the report and pass it to you. So now you have your own copy and I have my own copy. Which one is more efficient? If I just refer you to the web address, right? So this is the call by reference. But the thing is, when I refer you to the web address, now you have access to the document and you can actually modify it. So what we add is, in addition to giving you the web address, we'll make sure that it's a constant. You cannot modify it, so it's read only. So I'll pass you the address of this object, and this object is read only. If this object is read only, now this is a repetition now. If this object is read only, it means that all the functions inside the add function are not allowed to modify the calling object as well. So amount1 should remain constant throughout the whole function. What do you think? Okay. Now the example given, it's in example 11.4. So as you can see, amount1 is being passed as a constant reference, amount2 as a constant reference as well. Add and equals, are they calling anything? They're calling getValue, I think. If they're calling getValue, then getValue is a constant, and the output function is also a constant. Okay. This is the same as the example 11.3 that we have looked at last time. But if you recall, in 11.3, this was not passed as a constant reference. That's it. Okay. Now it's very likely that you're going to do this mistake at one point or another, which is you're passing the Excuse me?
It's just for a
The submission is on Wednesday,
Wednesday.
so you don't have to submit it now. Anyway, you can take it later on. Okay. Just if I look at the I-Lane and the submission is on Monday, you're in trouble, okay? It's on Wednesday? Oh, that's okay. Bye. Double check, Judge. Bye. So the common mistake over here is the following, is that amount 1, you pass it by a constant reference because it's much more efficient. However, throughout the implementation of the function between the two curly brackets, you find that you're calling another object which is allowed to modify the calling object. Modifying the calling object in this case means you change the orthants. This should not be the case. If you're passing it as a constant, it has to be constant throughout. So what's the solution? The solution is that for this function, which is called output, to be declared as a constant function, and this is how you declare it as a constant function. You just add the keyword const after the header. The keyword const after the header, what does it mean? Munib?
In your C++, it's promising us that it's not going to change the output of the function.
Yeah. So the function is promising us, the function itself, it's promising us that it will not make any modification to the calling object. Okay? So amount1.output, amount1 will not be changed. So I think you got it. Let's move on. Okay. As an extension to friend functions that we have looked at, there's also something called operator overloading. And operator overloading is the following. Now, again, same example, so this is easy for us to comprehend because now we are familiar with the many class. So how many objects do we have at this declaration? How many objects do we have? 3 objects, right? We have total, cost, and tax. We have 3 objects. And we want to say that total, well, after initializing cost and tax, we want to say that total is equal to cost plus tax. Now, we know that plus, it's defined for integers, for doubles, for numbers. Is it defined for strings? Yes, it is. What does it mean in strings? Concatenation, right? But it's not defined for the class money. We have to define it ourselves. And this is called operator overloading. Because the operator itself, which is the plus, it's not defined for the money class. We want to define it. So this is called operator overloading. This feature is not allowed in other programming languages like Java, but it's very helpful in C++. This would be the same as saying total is equal to add cost, comma, tax. We've seen this function before, right? It was a friend function, a non-member function. And you pass it 2 objects and it returns a 3rd object. Which one do you think is more natural, the first or the second? The first is more natural than the second, of course. Okay. So now instead of calling the function this way, we want to call the function this way. In this case, we have 3 things in front of us, right? And believe it or not, the function is the operator. We'll see that in a minute. And the arguments are cost and tax. Okay. So what we're going to do is the following. We're going to define this operator as a friend function. And if you overload any operator, you have to precede it with the keyword operator. So in a minute we're going to see operator plus, operator minus, operator equals, operator less than, operator greater than, operator cin, operator cout. So you have to start with the keyword operator. So now the name of the function is actually operator plus. Okay, but when you call it, you just call it using the plus. C++ will know that you don't have to use the keyword operator. What are we passing it? It's a friend function. A friend function is a non-member function, so there is no calling object. So we have to pass it, both of them. We have to pass it the first object and the second object. Okay. Then it says that at least one argument of the overloaded operator must be of a class type. Cost is of type money. It's a class type, right? Tax, it's of type money, it's a class type. Can we say, if we go back over here, can we say total is equal to cost plus 100? The operator plus over here takes two arguments and both of them are of type money, right? So we'll see the answer in a minute. But the sentence that we've read a minute ago, it says that at least one of those two has to be of type money. Okay? So we'll see the details in a minute. We know that friend functions, they're called without the dot because they're not a member function. This is a friend function. There is no calling object. We know this by now. Okay. Now, if this was a member function, if the operator plus was a member function, this is the way that we call it. Again, you did this in your homework, now you're familiar with this. So, at this line of code, we're rewriting the friend function as a member function. If you rewrite a friend function as a member function, you have a calling object, right? Okay, and this is the calling object, dot, the name of the function, operator plus, and then you pass it your money. Which two objects are being added in this case? My money and your money. Okay, so the old sense of the calling object and the old sense of the argument that we are passing, both of those are being summed up and returned inside the new object and stored inside some money. Okay, now there are some operators that cannot be overloaded. One of them is the new operator. Where did we use the new operator? In dynamic memory allocation, right? So the new operator cannot be overloaded. We cannot overload the dot operator. We cannot overload the scope operator. We cannot overload the... Yeah, this is for the dereferencing, not the multiplication. Dereferencing for pointers. And the question mark. Those cannot be overloaded. All other operators can be overloaded. Typically the operators that you want to overload are the equality, assignment, add, subtract, increment, decrement, input, and output. Okay. Now what does this say? It says that the money class with overloaded operators plus and equality, because we had a function which is called add, another function which is called equal, right? So now we're going to rewrite those as operator overloading. So let's look at the code.
Operator overloading can be a friend or non-friend member.
Operator overloading is typically friend functions. Okay, so this is the money class now, and we have a friend function which is called money. The operator plus, again, whenever you're overriding an operator, it has to be preceded by the keyword operator, and we're passing it amount 1, amount 2. The only difference between this example and what we did in 11.3 is the name of the function. So previously it was add, and now it's operator plus. Nothing else changed. Yes? No, you don't have to. But we're doing this now for efficiency reasons. Whenever you pass an object, you pass it as a constant reference. And the only difference between this and what we did previously was that was called equal. That's it. That's the only difference. Okay. And that's the only difference in terms of function declaration. Now, when you call the function, this is how the function is being called. Again, guys, just to refresh your memory, previously it was this total is equal to add cost, comma, tax. Right? This was the previous case. Okay. Now, you can also say, believe it or not, you can say total is equal to operator plus cost tax. The operator overloading can also be called using the traditional approach, which is ugly, of course. If I want to call it using this approach, what's the point of overloading the operator, right? But just to let you know that this will compile and this will run. This is acceptable, because operator plus is the name of the function. Okay? But typically we never do this. But just to let you know that this is what it is. So this is the function, this is the function. And the operators are cost, not the operators, and the arguments are cost and tax. Okay? Bye.
Cost and tax for the plus sign.
Yes. So the plus sign is the function and those are the arguments. Okay. And then we're asking the question if two objects are equal at one point or another. Here we go. Very natural, right? Very natural function call. So just saying if cost is equal to tax. But equals is not defined for the money class. We implemented that. Again, you can write it in a different way. You can say that if operator equals, and then I'm going to pass it cost and tax. And this is a Boolean function, right? So it will return true or false. So there's nothing on the left hand side over here. This is an expression that will evaluate either true or false. But again, if I do it this way, what's the point of overloading the operator? But I just want you to understand that it's actually a function call. Yes?
What should we do if we want to add more than 2 objects? Because we're going to have to use the plus sign more than once. So are we calling the function more than once too?
Yes. If there is more than, if you're saying object 1 plus object 2 plus object 3, the function will be called twice. We'll see that in a minute. Good question. Okay, so now we understand this. Let me also comment that's already commented. In terms of implementing the function, again, if you just replace this by add, or you replace this by equal, the implementation is the same. Nothing has changed. Okay. One more thing, and then we'll run the code, try to run the code. The automatic type conversion. This goes back to the point that we have mentioned. Can we do this or not? Full amount is equal to base amount plus 25. This is function called operator plus, right? Operator plus, it takes 2 arguments. One of them, both of them are of type money. This one is of type money, but this one is of type integer. Our function is not defined for object and an integer. It's defined for an object and an object. However, C++ is kind enough to do the following. Okay. So let's do the following example now. We're going to say that total is equal to cost plus 100. Okay. Again now, the function, which is the operator plus, it takes 2 objects. It doesn't take an object and an integer. So what C++ will do, it will do the following. It will look at the constructors for the money class. Let's see the constructors. Do we have a constructor that takes an integer? This is a long integer. Long integer and an integer, they can be cast without losing information. If you want to be, 100 can be treated as a long integer. 100 can be represented as either an integer or a long integer. There's no problem with that. So if you cast an integer to a long integer, there's no loss of information. If you cast a long integer to an integer, is there loss of information?
Yes.
There might be if the long integer was larger than the size of the integer. But in this case, it's 100. So 100 fits nicely into this argument, which is long dollars, right? So C++ will make the assumption that what you mean to say is this. What does this mean? This is calling the constructor, right? And you're passing it 100. The constructor, what does it return? It returns an object. The constructor of a class will always return an object. Okay? Right. What's the name of the object that is being returned over here? Let me take you one step back. Let's assume that we do the following. Money. Amount 100. At this point now, what's happening? The constructor is being called, right? And what are we passing the constructor? The number 100. The constructor, what does it return? It returns an object of type money, right? What's the name of that object? Amount 1. You know this. Right. Now in this case, we're making an explicit call to the constructor. Right? Look at the name of the constructor. What's the name of the constructor? Money. We're making an explicit call to the constructor. This we have not seen before, right? Because usually we call the constructor through the initialization, through the declaration. Now we're making an explicit call to the constructor, so this is new to us. The constructor will return an object of type money. What's the name of that object that is being returned? It does not have a name, right? It's nameless. We created a nameless object. This nameless object is now being added to cost. Okay, let me repeat that. So this is what we started with. We write total is equal to cost plus 100. Now, C++ will look at the declaration of operator plus. In the declaration of operator plus, C++ is expecting two objects of type money. But what it saw instead is one object of type money followed by an integer. So it doesn't match. But C++ will say, just a minute, I will give the programmer another chance. Maybe there is a constructor that will take a number of type integer or long integer. So it will go to the list of constructors and search for a constructor that takes an integer or a long integer. It finds one, right? So it will make the assumption that what you're trying to say is this. You're calling the constructor and you're passing it an object of type money. So it will make an explicit call to the constructor, create a nameless object with the value of 100, and then this nameless object will be added to cost, and then the result will be stored inside total.
Is it a good practice to do so?
Yes, it's very helpful. Is there a third way of doing this? Yes. Now look at this approach. Now we've created amount 1, and we just added to cost. Again, this is the same, right? We created an object, we initialized it with 100, and then we pass it to the function. But this one is easier, it's more natural. This one is more natural. Shift home. Okay. Now here's a question for you guys. Would it work this way? Do we have a constructor that accepts a value of type double? No. Long, integer, long, and default. So this will cause a syntax error. Okay. So C++ will search for the constructor and it will call the constructor. An explicit call to the constructor, which we have not seen before. Okay, so this is the first time that we explicitly call the constructor. So in fact, this is what will happen. So base amount plus 25 or 100, and this is the same as writing it explicitly, which is not the case. We don't need this, but just to let you know that we can also call the function explicitly operator plus and pass it base amount and also pass it the nameless object that we have created. You could have created the object first, like amount 1, and then pass it to the function, but both of them are acceptable. Okay. We also agreed that this will not work because we have a fraction, right? It's of type double and there's no constructor for double. Before we continue, let's pause for a minute, run the code, make sure that I answer your questions and you fully understand it. This code is not complete, so we have to copy stuff from 11.3. Fine. What do we need to copy from 11.3? Why does the author does it this way? I don't know. Okay, so operator overloading. Or we could call it CPP, yeah. Visual C++. Let's call it 11.4. Operator. This was example 11.4. or 11.5. We have main is there. We just need the implementation of those functions. They are in 11.3. I think we'll need this as well. We also need the constructors and the input and the get value. We need all of this. So let's see if it compiles now. We have an error. Function output, is it declared differently? It is another problem. It values function output. Function output const, just added the const keyword to it. And the get value, it also added the const keyword. You'll be doing this on your own, so it's good that you see me doing it. I don't know where this thing came from. Out is also a const function now. So let's try it again. One more error. Oh, this is we're experimenting with this, right? So this doesn't work. This should be okay now. No, it's not. Yeah. So this is the typical problem with the linker. No incremental bug build solution. And it's insisting okay. Money long integer referenced in function main. It's not declared. We're missing the declaration of one function, long and int. This is long and int. Is it being declared over here? So this is money long and int. Right click, go to definition. It's not defined. There's one more function that we did not copy. This function. Find next. Okay, so we need to copy this as well. Where are we? Okay, so let's run it to make sure it's running, and then we'll trace it. Are we running out of charge? 17 minutes. Start without debugging. Okay, so it seems to be working. Okay, so we have two questions. The The first question was, so we have total is equal to cost plus tax, right? Let's add the third one, which is called amount 1, and let's pass it 10 and 10. I think this is 10 for the dollars and 10 for the cents, right? Okay, so then there are $100, 10 cents. Okay.
So one is long, one is integer.
One is long and one is integer. And let's do this now. Munib asked this question, amount 1. This was your question, right? Okay. Now, what will happen over here is the following. How many function calls do we have at this line of code? We have 2 function calls. And the first function call is this, which is tax plus cost. What will it return? It returns an amount. It will return an object. The object that is returned, it will then be added to amount 1. So it's as if you're doing this, right? And let's convince ourselves, let's have a breakpoint and convince ourselves that the function is being called twice at this point. So debug, start debugging. Okay, so now I'm going to step into the function. Let's see what we have inside cost. The old cents is 150, for the tax is 15, and for the amount is 10,010. Okay, and let's step into the function. Right, this is the first function call. Amount 1 is 150 and amount 2 is 15. So this is tax plus cost, right? Okay. It will create a new object and it will return it. The new object, it will contain the summation, which is 165. This is being returned. I'm going to step again, and it's going to send me again, but now this is the second function, right? So we're done with the first function, now this is the second function. So I'm going to step into it. And now the first argument is 165. Where did 165 come from? It's the summation of the cost plus tax, right? And the second argument should be the 10,000. And so if we step into this now, it will create a new object. This new object contains the total sum, and it's going to be returned to total. So you don't have to, if this question was, do we have to create the operator plus with 3 arguments or 4 arguments or 5 arguments? No. In fact, if the operator plus is defined for 2 arguments only, when you overload it, you also have to overload it for 2 arguments. You cannot change its behavior. Plus always works 2 arguments, right? You cannot overload it with 3 arguments. You cannot overload it with 1 argument. It's always 2 arguments. You cannot change the behavior. Okay, and then it works in a natural way. So you just define it once and you forget about it. So you want to call it more than once, you just deal with it as if you're dealing with integers, as if you're adding integers. So I can add 4 objects, 5 objects, 10 objects, it will work perfectly well. So this was the first question. Now the second question is this, right? I'm going to step into this function now. Where would it send me? No, no. It will not send me to the operator plus. I think this should send us to the constructor. It will call the constructor, pass it the value 100, create the object. It's a nameless object, and then add the nameless object to the cost. So let's step into it. Here you go. Here you go. It's called the constructor directly, right? It's taking one number, and all cents is equal to dollars times 100. Why is it multiplying dollars by 100? Because it's stored as all cents, right? Okay. Now we go back, and now we have, instead of 100, we have a nameless object. Okay. Now if you step inside it again, where would it send us? To the operator plus. Now it will send us to the operator plus. And the first object, it's 150, and the second object is this is the 100 times 100. So this is the nameless object that was created. And now both of them will be added up, and total will be equal to the summation of both. Now you're convinced, right? If you continue, nothing of interest over here. Okay, is this a function call now? It will call a function, right? Cost is 150 and tax is 15. Let's step into the function. It's a function call. Okay. Amount 1 is 150, amount 2 is 15. Are they equal, no or not? So it's going to return false. If it returns false, then it's just going to skip to the else part. Yes?
Why is the watch being updated?
What's not being updated?
Just like the name and value.
Which line? This line? Which
So
line?
like down there's a box name and value.
Name and value. Because this is watch. If you go to auto, or if you go to local variables, for watch you add whatever variable that you want explicitly. So I'm going to add cost. And it will give you the what's stored inside cost. This is called watch. If you go to local variables, this will give you all the local variables. So you're either interested in local variables or you're interested in watch. In watch you can add whatever variables you want. You know this, but just to refresh your memory. So I can add tax as well, and I can look at the contents of tax. Okay. More questions? Let's do one last thing. Let's make sure that this will also work. Does it compile first? It does compile. Start debugging. But step over now. This is the function code. We want to step inside this function. Where would it send us? To operator plus. So I just want to show you that calling the function, the overloaded operator, in a natural way, or calling it explicitly, will have in fact the same effect, right? But it's ugly to call it this way. What's the point of having operator overloading if you want to call it this way? But just to let you know that both are the same. Okay, so this will return an object, and total is now equal to 165. So that's it. Bye. To save you the trouble, I'm going to upload this code, the 1115, because the code wasn't complete. I'm going to upload it to iLearn. So later on you can download it and have a play with it if you wish. Any questions? Okay, thank you for your attendance.